In older buildings, in older walls, you are not going to cure the dampness. You can only ever manage it. The choice of specialist materials, feebly hydraulic, fully hydraulic limes, polzanic agents, a whole plethora of different mixes suitable for the purpose. These walls certainly don't need chemical damp-proof course injections.
And neither do these. This is Cor Castle, ancestral home of Richard Good Stevenson, who as a child always dreamed of living here. Unfortunately, when he was a child, it looked like this. So he had a bit of fixing up to do. And after a lot of hard work, by a lot of people, it looked like this. Mike went to visit him to learn of some of the challenges involved.
Obviously, a building like this is vitally important that it's allowed to breathe. A common mistake made by people when restoring old buildings is they use modern materials in the restoration which are totally incompatible with historic buildings. And because this building is a solid masonry construction, the use of lime mortars and plasters in it were absolutely vital. And in fact, we haven't used cement at all.
And the facade of the building, which is now rendered, I trust that that's been done in non-hydraulic lime.
Actually, we've done a combination of both. On this particular building, we've used hydraulic lime on the facade which faces the weather. The prevailing wind here is from the southwest, so we can almost have two climates around the building when we have bad weather here. The north side is very, very sheltered, and the southwest side can be actually absolutely exposed to a gale. And as you know, in Ireland we get our fair share of rain. So we find that the natural hydraulic lime on the southwest elevation is been very effective in allowing the building to breathe and also giving an extra additional protection layer on that.
So what are approximately the thickness of the original walls that have the lime render on?
They're approximately about 30 to 40 inches thick. They vary from part to part of the building.
So the whole management system here of coping with the extremity of the weather is obviously the rainwater is going to penetrate into approximately about 1/3, about 30% of the exterior wall. And of course the lime will then allow the evaporation and create the breathability factor.
Absolutely. It's absolutely essential on these buildings to understand that's exactly what happens. And one of the reasons why they built the walls as wide as they did was exactly that.
This natural drying process produces the ever-shifting patterns in the lime wash, which are part of the organic appearance of the material.
There's a great deal of preparation that goes into preparing the substrate to accept the lime in the first place.
Absolutely, Mike. One of the biggest jobs we had on this project was to repoint the building, top to bottom, inside and out, as included all the internal walls as well, of course. And as you say, the substrate must be tight and firm to accept the lime plaster. So it meant raking out all the loose mortar between the joints and then reinserting lime mortar, giving us a firm base to apply the render to. Yeah.
Did you actually find, when you were preparing the substrate and you were raking out the mortar, did you actually find that what you were raking off was originally lime, or did you find that somebody else had been tinkering with the building and perhaps put a modern cement on there? Or
we were very lucky with this building because it's been derelict for 80 years. It had been untouched as far as cement was concerned. So in a lot of cases you do find that where people have repaired in cement over the years, and that can cause additional problems because cement, as you know, is very, very hard and rigid. And if the masonry is soft, it can do a lot of damage when you're removing the cement which has been applied incorrectly in the past.
So if we went with an ordinary Portland type cement, for example, and we put a hard render on the outside of the building, then the water's going to go in and not evaporate back out. So it would actually be disastrous for a building of this age.
Absolutely. I can't stress that enough. These buildings obviously were never built with solid foundations like we do today. They were designed to be flexible and to move, and of course lime allows that to happen. When you put a hard, rigid, cementitious pointing or render on, as the building moves with the seasons, maybe only millimeters, it develops tiny hairline cracks, and these hairline cracks allow the moisture to come in, but because it's not permeable, it doesn't allow the moisture back out again. So you've got a build-up of moisture which eventually ends up on the inside.